So we'll look at one by one. So by starting the history, so when we look at the history, it has been developed by Jane Stroustrup. We can see C++ as a superset of C language. While Stroustrup doing his PhD, he started working on C++ with classes. So C is the most powerful language. It lacks of giving the OOPS concepts and some other criteria. So he started research on this and adding advantage of OOPS into C, the existing C language by doing that project, and progress starts by 1979. So that is where he started his research on it. The first commercial release is done at 1985. After that, we have major releases in a 5 phase, like 5 versions so far we have got from the C++ organization as an organization. While developing this C++, the main thought in his mind is about without sacrificing the speed of C and with OOPS. So he has done a good job on this. The major releases has been done from the C++ are C++ 98, C++ 03, then C++ 11, forward by 14, then 17. Now we have got C++ 20 as a preview edition from the official C++ organization. From these, we can understand C++ is serving the software industry for more than 3 decades, and it has been doing his great job. So what are the core benefits that we have using C++ for the software development? Well, there are many things. Let's take examples. So statically typed, then fine control over memory, then cross-platform. So what is a statically typed things? So whenever a variable is being declared, it has to be of certain types. So modern day languages, you can see, you can just by typing a variable or the variable name, we can assign the values to that. So C++, which is not like those kinds, which is pretty straightforward. We have to declare the variable type like integer, character, or float, or else bool, like these stuffs. So which gives type bound. That is called a statically typed language. So when we come into the next one, finite control over the memory. I say it is a great gift provided by the C++. Why? Because very few languages in the market is giving these options to the end developer. So C++ is one of those few options, and which a powerful back language. That is why I'm telling it as a gift to the developers. So most of the developers are afraid of using this, taking the control over the memory. So, but I say it is a gift for the developers. Then to the cross-platform things, which is like I wrote a code or a sample project or a simple one, which I have done through Windows or Linux. I can run the same code on other platforms like Mac or Windows or even embedded devices without even changing a single line of code. That is how it is designed. So I will see how it has been done in this webinar in the upcoming sessions. Then moving forward, so what are the trends which has been delivered by C++ to the modern industries? Everyone may know about IoT and AI are the booming industries. C++ is doing the job pretty well on those domains. If we look at the IoT industry, it is like a tiny hardware specifically developed for some simple operations like watches, some small kind of devices. So to run the very complex programs or some data logics into the hardwares, like most of the IoT devices will be like microcontrollers, not being a microprocessor, it is like a microcontrollers, which affords a small memory footprint. C++ is a great tool to run to meet the demands to running on the on the hardware side. That is how IoT industry has been dominating by C++. Then coming into the AI, so everyone will think AI, they'll thought about the Python. So I do, of course, yeah, Python is doing its contributions very well. But under the hood, if we see, the complex algorithms were built using C++. Why it has been developed through C++ is because of the fastness and the more powerful language, the rich in library contents, all being with powered by OOPS. When coming to the AI point, one more thing is we have to do lot of data operations. So there is a need to organize the data pretty much. So C++ is giving those things by its own struct and classes. As an example, this is the concept from oops, so we'll see about it. We'll see some of the examples in the upcoming slides. So what are the libraries which has been done through C++ for the AI industry? Then moving forward, low latency programming. So wherever the program has to be executed faster, the industry is like banking, high frequency trading like foreign exchanges, crypto tradings, they were using low latency programming. The major contributor for the low latency programming is C++. So next, moving forward, we'll see about the roles of C++ in the daily usage. By knowingly or unknowingly, many of them are using C++ under the hood. So everyone today's world will be aware of using computers day-to-day usage. It is like our day-to-day usages. So every system is being powered with an operating system. Those three I listed are the major contributors on the operating system side, like Windows, Mac, or Linux has been powered with the help of C++. So everyone is using indirectly using the C++. That is how we can say. So then coming to the browser side, so browsers having an option called rendering engines. It's a mechanism. So what it will do, I'll explain you. To get the HTML or CSS from the servers and converting into the UI tools like buttons, it may be your buttons or text contents or animations or pictures or the color gradients that we are seeing in our web pages has been done through the rendering engines. So most of the rendering engines has been designed with the help of C++. The most advanced one is science and medical. So it is an emerging, it's ever-growing technologies. We can say it as ever-growing technologies. IoT is been playing a lot in these industries. So earlier, like we see, IoT has been powered one or the other way using the C++. So I will say traditional examples that when we go into a medical or diagnostic centers, we'll see a lot of devices like ECG, scan, X-ray, therapeutic devices, like everything, which will be powered by C++. Then oscilloscopes. So wherever signal processing is needed, C++ will do its contributions. So like science industry, majorly oscilloscopes or some measuring devices, C++ will do its jobs great. Then we'll see some more examples. Continued from there, as a developer or software developer, he can come from any background, like other languages, Python or Node or JavaScript, anything. They will use these tools in their day-to-day usages. So compilers. So most of the compilers is being designed with the help of C++. The listed two things are C, GCC and Clang, which is purely done through C++. Then to the database part. So every web page or web applications will seek for the database help to store the contents. So those things, so the traditional databases from MySQL and Postgres, so which is being done through the help of C++. Then like AI algorithms I told, right, as earlier. So libraries like TensorFlow, Caffe, NVIDIA DeepStream. So these are using the C++ things. So TensorFlow is from the Google's, then Caffe. NVIDIA is doing his job like image processing things. So image or video processing, we can say it as video processing. So there C++ is doing the contributions greatly. Then some more examples. C++ actually is doing in each and every industry, it is contributing a lot. Some simple I have listed here. So, and the backend services like Amazon, Google or Facebook, like as like earlier we see, every web applications is using databases. They are not, they can't skip those things. So Amazon, Google and Facebook is of course using it. Then Google's search engines are developed using C++ with its core part. Everyone may know about it. Then to the more advanced science, aerospace industry is also using the C++ by directly or indirectly. Directly means they may use IoT sensors for data collections, other stuffs. They will use the IoT, which internally is using that C++. And the indirect usage, we can say about like simulations or design softwares or 3D modeling softwares. Simulation softwares like MATLAB or its kind, then design softwares like Adobe of its kind, then 3D modeling. Everything will be powered by C++. So then coming into the game industry, which is a most dominating industry by C++ from the earlier days. So 90% of the game engines has been developed with the help of C++. Why it is like? So C++ will give the hardware interactions much faster than the other when compared to the other languages. So which is of course, so game needs has high performance or high rendering capabilities for the smoothness of games. So modern games, we can say whatever it is, most of the game engines is being developed by the C++. And the companies which are strict with C++ are some examples like Unity and then EA, which they are doing games as well as preferring their own game engines. Most of them are developed with the help of C++. Then some other industries like banking, high frequency trading, many exchanges are using high frequency tradings, right? In a day, maybe millions or billions of transactions they have to handle. So the program has to be very low latency. So C++ is obviously a good reason to go with the banking and trading sessions. Then to the networking sectors also. What makes the C++ the most powerful one? So every industry it's doing good job with the help of C++. So there is something with C++. They are living for more than 3 decades in this industry. So the major thing is they have covered with OOPS. As a basic building blocks, everyone may know about it. Classes and objects is the basic building blocks. Then coming into the next sessions of the OOPS, abstraction and encapsulation. I want to create a library to expose the outside world out of my company. So I don't want to show the functionalities of those library. What I can do? So I can give the common APIs and I have to do the job. So it may be a little technical. So how we'll see how C++ is providing those accessibilities. With the help of access specifiers, built-in access specifiers in C++, example is private and protected keywords, which is there in the C++, one of the access specifiers. With the help of those, we can encapsulate the data and give the library the external accessible APIs. So there it is, it plays a role much more than we think. Then polymorphism and then inheritance. So inheritance is the same concept. There the access specifiers will do its great job. Polymorphism is, earlier I told it is statically bound, right? So with the help of statically bound, if we change the signature of functions, like it has to be a typed one. So thereby it is providing its good job there. So then we move, so we'll see about the pointers. When we coming into the pointers in C++, we refer by using the asterisk symbol. When I say pointers, it is a double-edged knife. So we have to be very careful and very cautious in using it. That is why most of the developers are afraid to use it. And they are thinking it is an overhead of C++. But I say, like I told earlier, it is a gift to the C++. Wherever there is a risk, there will be reward. So what are those rewards? We'll see. So we can access the value directly by telling the address. So someone is coming to deliver your goods which has been ordered through Amazon. So if they tell your name, everyone may not aware of your name. If they tell the door number, it is easy to access, right? The same concepts has been provided by the C++ in form of pointers. That is what direct access C++ is providing. So instead of telling the variable name, I'll tell the address which has been inside the memory. So they can directly read or write into the memory the required data. Then coming to the pass only address. What are all those? Doing a software program or complex program, we can't write all the codes in a single function. So we have to make hundreds of functions. Through those functions, we have to pass our data here and there. So if we have a data structure, if it takes 2 MB of size in a running memory, so we can't, every time we can't copy the variables one after the other. So what C++ is doing is providing us is pass only the address. So if we tell the starting byte of the address, so there is no need of a heavy copying will happen. There is no need of copying the heavy data structure each and every time. So thereby it is giving the accessibility to pass only the address. Then to the dynamic memory allocation part, it is in software industry we'll say like lazy initialization. I can tell you an example. So if we're launching an application in your Windows or mobile applications, maybe it is doing an image processing. I don't need to load the all the classes or objects at the initial way. I can create a null pointer and do the required things for that particular screen, launch the applications. Whenever the user taps on certain button activities, I can load the objects into the null pointers. So that is how a dynamic memory allocation means. So these are all the options C++ is giving to the end user. So next, moving forward, when coming into the C++, not only C++, every language has to come with its own libraries. So C++ as a powerful thing, it is having the STL libraries. STL means standard template libraries. What are all those? They are having the four major components like containers, iterators, algorithms, and functions. Something which we will use to store our data. So the types are list, queue, pair, vector, stack, and map. So one or the other form we have to store our data based on our convenience and ease of access. We can use the direct libraries provided by STL, which has been officially recognized by C++. So we can use those libraries without write a linked list from the zero. We can start using the already available libraries. That is how it has been using. So iterators, we have put our data inside the containers. How we will access the data? Anyway, we have to look through the data, like forward mechanism or backward mechanism or a random mechanism. Those functionalities are already embedded in the C++ STL libraries. So there is a great advantage. Then coming to the algorithms part, like earlier told, it is a great option to implement the algorithms or data structure parts. C++ is a good to go ahead with the implementations. So STL is providing some of the basics like search, sort, union, intersections, and difference. These algorithms has been already available with STLs. Then to the other functions like qsort or comparisons, it is doing its job pretty well. Yeah, and not only these things. So STL is backed with more than 100 built-in algorithms. It is having a great option to explore the STL algorithms. Once who know the things very well, they can contribute to the C++ very easily. They can come into the domain. That is how I can say. Yeah. First, we see the cross-platform compatibility. So I'll explain a little bit more on that. So everyone may aware. So C++ ends with a suffix of .cpp file. That is our source file. So if we run a source file in a Windows machine, it will adapt itself and create a binary for that particular machine. That is a Windows exe. If we go into Linux, it will create an exe that can run on that specific system. So we no need to change our source code. The compiler is being designed specifically for that operating system. So it can convert that C++.cpp file into an object file. Then it can create a exe out of it. So the object creation, since it has been done through the compiler, we no need to worry about it, so that our code will be designed only once. We no need to change a single line of code. That is how it is working. And since Linux, Windows, and Mac, everything is being powered with the help of C++, it is already having the STL compatibilities available with them. That is how we can able to achieve it, cross-platform compatibility. And can say some examples like Qt, which is a well-known GUI library which has been backed by the C++. So it offers a cross-compatibility not for these three things, and for Android, iOS, modern embedded devices, even without changing a single source of code, it will run in a microprocessor also, like a modern day STM or tiny devices, we can say. So it is providing a lot of options through this cross-platform possibilities. So what is the advantage of these things? A company can hire only one person without changing a single line of code, right? They can able to deliver their softwares in the three different platforms. That is how it is doing its job pretty well. The typical job roles that a C++ developer can see, like whenever they see game programmer, we'll see about its roles also. So whenever they see game programmers, I'm sure 90% it will be like for the C++ developers only. What are the major roles? So they have to develop the game engines, or they have to contribute on the user interface sites. So that is their roles. Then embedded engineers or developers. It is a mix of hardware and software knowledge. So in the software side, we have three layers like firmware, middleware, and then application layer. So these embedded engineers will mainly focusing on the firmware and middleware part. That is the job roles which defines the embedded engineers or developers. Then algorithm developers, like we see have seen earlier, right? Most of the complex AI algorithms has been built through C++. So what are their roles? Wherever signal processing is needed or wherever mathematical modeling is needed, they can be achieved through complex algorithms. So they need in seek of C++ help. So C++ developer has to play their main role on these areas. Then software engineers, like in a bracket C++, they'll mention. So what are their roles? So majorly they'll focusing on the application development part. So for Windows operating system, they have to create an GUI interface like Skype or some other normal commercial applications, or it can be a service also. So it will do its background job, syncing the data from server, or internally it is doing some triggering notifications. These kind of things is like a their roles, software engineer roles. Then specifically for the Linux developer, we can able to see C++. In these roles, they'll be mainly focusing about embedded parts, or else they'll deal with the middleware and firmware part. This is the same kind of embedded Linux or Linux. Yeah, they are the same. So how to get into this growing domain? So we have to, sure, definitely we'll know about C++, a basic programming knowledge, then a strong in OOPS, specifically C++ OOPS concepts. However, it is there are many keywords for those things, so we have to be handful of experience on those things. Then insights of debugging and compilation. Everyone can write the code, but whenever it is coming into the production, we'll see issue after issue after issue. How to do those things? So we have to an idea about debugging, how it is doing. So we need that idea. Then how compilation works. What is the background? Like I told, that C++ has been compiled. Then compiler is generating an object file. Then it is generating the exe. These process we have to have a little idea, not more than. I'm not expecting 100%. I'm not telling about that. So it is little required. Then to the skill functionalities. I told more than 100 libraries are there available with the, sorry, not 100 libraries, 100 functionalities has been available with the STL library. We have to be handful on those. We have to be much experience about it. So if we practice day by day, then it will come automatically. Then into the memory management. So as like it is a double-edged knife. So we have to handle it wisely, or else it will punish us. We can see memory leaks here and there. Then our application becomes unstable. So this is a very important concept when we look at the C++. So we have to study on pointers, what are those references, then how to avoid these things by the intelligent way of using smart pointers or unique pointers. These kind of stuffs we have to know about it. Then little bit of design practices. Design practices in the say, it is like a beginner level. Yeah, major usage of design patterns are mainly like singleton pattern or a factory pattern. These kind of stuffs, if we know about it, it is very easy to understand these concepts and try to implement some of those patterns in C++ way. So they are having the generic pattern, we have to design in the C++ way. If we try it once or twice, it will be very easy to come into this domain. Everyone is thinking C++ is not in the industry anymore. So I say no. How? Why? Because it is doing his job silently on the background scene. As I, as a 4 years of experience, I can say it is doing its job pretty well. Everywhere we are moving to the IoT, then to the AI. The underlying library, which has been most of the libraries has been developed through C++. We have great opportunities with C++. Actually, we have to be grateful for the Jane Strauss who developed this language. Yeah, that is how I can say.